Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So good morning again, everybody. Welcome to the sensor data session. I'm Stuart Townsley, Research Program Manager for Device-Oriented Computing at Microsoft Research External Research, your host for this workshop. I'm not going to give you a whole spiel of introduction, so I'll get out of the way for Deb. Let me introduce Deb Aguiral. Thank you.
Thank you. So I'm going to talk about an aspect of sensor data, which is actually going to be tied more to how to get people to collaborate on sharing their sensor data at some level. So this is work we've been doing at the Berkeley Water Center in coordination with University of Virginia, and actually Microsoft has been heavily involved as well. So let me give you a little bit of background on this sensor data network. It's a global network of carbon-flux sensors that has been put in place over the last 15 years. And the idea there is to be able to measure the carbon exchange with the atmosphere for each of the different biome types. Right? And the idea that they want to be able to do is to be able to characterize that carbon exchange such that, you can think of many different reasons, but, one of the easy ones is global warming, right? When I think about global warming in the large climate model, what would I really like to be able to do? I'd like to be able to take it to a much smaller scale, be able to tie it to the land processes, and be able to actually then have some real data that says exactly how do the land processes operate. So a lot of the data from this network is very critical to doing that. And the typical way that they've shared information about their sites and about the data in the past has really been at meetings, small group meetings at the large conferences. So one of the big ones where they all talk together is AGU and EGU, right? So the American Geophysical Union, the European Geophysical Union. But as they built up this worldwide network, the next step that they really wanted to do is to be able to say, well, now that we have all this data, we'd like to bring it all together and be able to start to do synthesis activities and figure out what we know across the globe and across these biomes. What have we learned so far from this data? And so the first attempt at that was in 2000. And at that point, when they brought together the data, they managed to bring together about 38 sites. It's about on the order of 90 site years. And they used that to then do some synthesis. That resulted in about, I think it was 15 papers. Yeah, it resulted in about 15 papers. They created a special volume in 2002 that had the synthesis results that they'd done. Now, as is completely obvious from this amount of data, they didn't have a whole lot of statistical significance across saying things about biomes at that point. There just wasn't enough data at that point. As of 2007, though, they had a lot more data that they'd collected around the world, a lot more towers that had been put in place, and so they held another workshop. And at this point, they had 253 sites that participated in bringing data together for this collection. Ended up with around 960 site years. It's a little bit more than that, but give or take, since some of the years are partial, it probably counts out to about 960. They also had dramatically increased the number of variables that they were measuring, because the original synthesis effort, you really started to realize that there were a lot of things that people weren't measuring that needed to be measured to be able to do these activities to look across the biomes and really understand what was going on. The other thing about that data is that the quantities they're trying to measure are very difficult to measure, right? Some simple ones that are completely obvious to anyone that it's incredibly difficult to measure. Leaf area index. Leaf area index is trying to measure all of the leaf area in their canopy, if you're talking about a forest. So there's one way to measure it, that's completely destructive and tells you exactly how much is there. Of course, you'll never measure it again. So the reality is they have to do derived quantities, right? There's a lot of ways that you can measure effects of that leaf area canopy and then derive what that canopy must be, but you don't necessarily have an exact measurement of that exact quantity. Same with the carbon flux itself. If I'm trying to measure what the storage in the canopy is of carbon, another thing that's very difficult to measure myself, by going out and getting some exact measurement, but I can get a derived measurement that in fact is based on some other quantities. So the key here that I'm trying to point out is that this is sensor data, but it's not simple sensor data. It's not data where every measurement is exactly the quantity you wanted to end up with and is exactly measuring the thing you wanted to measure. In fact, many of these measurements are in order to derive the thing I want, right? And the other thing is, at this point we now have 70 synthesis papers that are underway at various stages of completion. A few of these have already been submitted to journals. Most of them are still in progress. So let's talk about the data flow. Where does the data go? So it starts at each of these measurement sites. It's actually measured at a fairly high frequency. They then convert it into half-hourly measurements. They then submit it to their regional network. These towers are actually organized in regional groups. So there's an Ameriflux group, which is North and South America. Not quite all of it, because there's there's a Canadian flux network. There's now a Brazilian flux network. So some of these are sub-regional networks. Carbo Europe is a very large group. There's an Asia Flux. Carbo Africa, there's a broad array of these regional networks. They work with the tower owners, they gather the data up. Then what happens, now this in particular, once you get past the regional network, I'm talking about the synthesis activities. And when we're gathering up a large data set for the synthesis activities, the next step that happens is that a group has typically been brought together who can then do the quality assessment and gap filling. A lot of the synthesis activities can't actually deal with the raw data. The raw data typically has a lot of gaps within it, and if you're looking at models and other things, it's very difficult to use gap data and also data with spikes and other problems from the sensors. So the group actually in Carbo Europe, this time, actually both times, have gone through and done all of the quality assessment and gap filling. Right? So at the end of their process, you've got one consistent method of quality assessment and gap filling on the entire data set. So at that point, it comes to us, and I'll talk a lot more about the site that we've created and what we've put in it as part of this. As of 2000, they didn't actually do this. This next step was not here. In fact, that was the last step of the data process. And each group that was doing synthesis then took all of those data files, did everything from there. Okay, so that was their old process. What we introduced is actually a collaborative site and a data sharing site, and I'll talk a lot more about it, where we've actually put the data and built a lot of tools for the collaboration to use in doing the synthesis activities. And so now what we have is that for any of the synthesis activities, any of the site investigators who want access to that final data, they all get it through our site. We provide data summaries, we provide a lot of additional features, we provide a lot of collaboration support. And I'll talk about that. So let's talk a little bit about how they collaborate and who they need to talk to when they're doing a synthesis activity, because it doesn't help if I show you a bunch of tools and you don't understand sort of who they're talking to and why. So when a synthesis paper team starts working on their paper, there's a lot of things they need to do. Right? So one of the things they need to do is they need to look at all of the site data and figure out whether it fits the particular synthesis analysis they want to do. Right? So one of the first pieces is just evaluating the data itself. Does it have the sort of measurements? Is it in the right type of climate? Does it have the right type of vegetation? Those sort of things. Once they decide that they want to use a particular site, they actually have to talk to each of the site investigators and get their permission to use that data. Now, they provided a blanket permission that this is provided into the synthesis activity, but now they actually have to provide an abstract of what analysis they're trying to do to the PIs and ask the permission to, in fact, use that data for that analysis. There's a couple of reasons for that. One is because the PI might already be trying to do an analysis similar and might want a little bit of time to publish their result. That's rare since these are synthesis activities and across sites rather than within a site. But also, the PI gets the opportunity to participate, if they'd like, in that analysis. Since otherwise, one of the big issues is that these groups are gathering this data. It's exceedingly difficult to gather. It's a great deal of their time and effort. And they don't have a method of publishing the data itself, right? And so for them, the critical aspect is getting credit for having taken the data when any publications use their data. Right? Because otherwise, they don't manage to get funding to do the next year's data collection. And so all the synthesis activities lose, and they lose. Right? So in the end, it becomes very critical to support that incentive structure itself so that, in fact, you have that the site PIs are participating and are, in fact, glad to give the data into the activities. Another piece that I left out is this steering committee. So the steering committee was formed because one of the obvious things is, you've got 253 sites. How are you going to decide what synthesis activities you're going to let go forward? And how do you start to bring together ones that are overlapping? They formed a steering committee. The steering committee does approval of all synthesis activities. So everybody who wants to do something, a synthesis activity submits an abstract to the steering committee. It gets approved or not approved by that committee. And the committee actually has the regional networks on it, so they're looking out for the interest of their PIs. So then, as I mentioned, they're going to come to our site then for all the data access, summaries, a lot of their data selection, collaboration support. Again, I'll talk about that later. And then, there's a lot of collaboration with the folks that did that quality assessment and gap filling. Right? Because a lot of their results are going to depend very heavily on whether or not that was done correctly and what assumptions were made while that was being done, and the quality assessment and on the gap filling. So now when we look at who are the users of the data portal and the data itself, there's actually a wide array of users. There aren't just the synthesis teams. I always have trouble with that one. So the synthesis teams are one of the prime targets of providing a collaboration portal, but they're not the only target. Okay? So first off with them, I've already mentioned we want to support the site selection, their data access, their analysis itself. But we can't forget that, in fact, the site measurement scientists themselves need support as well, because they're now going to interact with the synthesis teams. They need to be able to check their data. They need to be able to submit more information about their site as information is needed. And also just to sort of build that level of transparency of the collaboration so that they can learn to trust the synthesis teams and understand exactly what's going on within the collaboration, how their data is being used, and feel confident that they're going to be able to be part of the process and get credit as they need to. The other really key group is actually the public. And at first you say, well, why would I care about the public? Well, the reality is the public is one of the most important users, because really you don't want to have that most people need to have access to the site to learn anything about what's going on. Because, as I mentioned, one of the ways that I get into the in-crowd is I submit a proposal of what synthesis activity I'm going to do. If I can't find out anything about the data set, I can't figure out whether a synthesis activity would be worthwhile or not. So in fact, I need enough information to be able to figure that out. And at that point, I'm a public user. It's also critical to these groups. I mean, I've already said it's hard measurements. They're around the world. They're spread out. They're different investigators. And it's been being done for around 15 years. All things that make it hard to keep your funding stream going. So in fact, having the transparency to the funding agents because they're also not a synthesis team. They're not somebody collecting the data. Having that transparency to them so that they in fact can see how the data is being used, how important it is, what topics it's being used for is truly important. The modelers are actually not originally part of the synthesis activity, so this was a good way of being able to provide them information about what's going on. And also just to keep people informed of the general activities. Okay, so the next thing I'm going to talk about is really the collaboration portal, but before I do that, I want to talk about the philosophy we used in designing this portal, because I think that's critical to understanding how we put this together. And again, the first one, the barrier to entry really goes to having put as much information as we could in the public use area so that people can learn as much as they can and get really interested in using this data set from the public access, right? So they have an incentive to actually go off and get the access. Another really key point that seems completely obvious or almost brain dead that I put it on the slide, but it's so critical, is we're a group of computer scientists trying to build something for a set of scientists. The temptation for us, is to actually go off and build really cool computer science. That's nearly useless to the science community unless it's completely targeted at exactly what they need. And in order to do that, I think one critical point is you've got to get familiar enough with the science to actually be able to do that. I mean, most people think, I sit here in the talk and I talk about Carbon-Flux and you say, oh, well, she had to get familiar with it so she could give this talk. No, it's more critical that you actually are familiar enough with it that, in fact, you can help them to get the functionality that is most useful to the science. Because they're not even going to be thinking about it necessarily in the front of their brain because they just do it naturally. It's obvious to them that that's the way you approach things. I mean, a simple example I gave last time at the eScience meeting is actually that, once we were working with some watershed scientists, and to us it was completely obvious that a year is January to December. No, it turns out there's water years. They start in October. As soon as you know that, you can build everything around that there are water years and life is good. So let's step through the portal before I run myself out of time. So we have a home page. This is all at www.fluxdata.org, so people are welcome there. You'll see that a lot is in the public space. So let's start with the public view. So you see a home page with some basic announcements, things like that, and all the links. By the way, obviously built-in SharePoint, which turned out to actually work quite well for us. We have a blog that keeps people up to date as to the latest changes to the site, changes within the collaboration. This then is an exceedingly critical page. What we do on this page is actually every one of these items is a link to a spreadsheet. And there's summaries, there are explanations of the data, there are lists of the half-hourly variables, there's an incredible amount of information all here, and this is all in the public part of the site. Another thing that's in the public part of the site that you'll see is actually a full list of the synthesis teams, their proposals, and then if you click on the view button, actually what sites they're currently indicating that they plan on doing their synthesis activities using. Right? And we have search tools so that someone like a funding agent could come in and say, well, who else is using this site that I'm funding? And they can use that search and they can find the synthesis papers that are in fact using that. Right? So there's a lot of things to help make it really easy for the site PIs and the funding agents to get that feedback of who's using my data? Why is it important, right? Easy ways for them to tell that story. So I mentioned that the data download was here. And so this is their method of doing it. They actually select what sites, what years of data they want, what format they want it in, and then it provides them links on the next step, and they can download that data. So now we're getting into the private space, and this is only available to the synthesis teams, this part of it. And so here what you start to see is actually some of the really critical data. And in fact, that's not the FluxMet data, which is the data measured at the tower that I mostly have talked about, right? That Carbon-Flux data. What's actually exceedingly critical to the synthesis activity is all the other information about the site, right? What kind of a biome is it? What's the soil moisture profile look like? What's the soil texture profile look like? All this information about what is this site, what characterizes this site, because when they're trying to abstract up to what can we say across the globe, that's the first thing they need to know, is what's different about this site, what's the same about this site with other sites. All of that information is then linked off of reports on this page, as well as some of the access to aggregate information about the data. So another thing that we've implemented is, as the synthesis activities work on things, they need things from the PIs. The old method was you send an email to the PI, you ask them the question, they send the email back to the synthesis team. So none of that gets captured then into the underlying system, such that the next synthesis team would actually know that. So what we've done is we've implemented a page where the PI can come in, they can select their site, they can select the variable, and they can go ahead and provide the new value. And actually in here, if there were some submitted values that were still waiting for acceptance, they'd also see those listed. So it in fact shows them everything in the current status of where the data is in terms of going through the process. So they know if somebody already submitted it, they don't need to resubmit it, things like that. And in fact, I said the PI could come in here. Well, in fact, anybody can come in here who's authorized to the site. And that's really critical, because what that allows is now the synthesis teams can do it as well. So the PI has a way of looking at what we know for their site for all this ancillary information. And this is info about my site. If I'm a PI, when I come in, I have a list of my towers. And I can then look at all that data myself and see whether or not they have accurate information for my site. I can print out all of this information. Okay, so back to my philosophy slide, but now looking at what within the portal did we do to actually uphold that philosophy and actually bring that into practice. So I think the barrier of entry, clearly we put as much information as we could. We put a lot of aggregation information about the data, a lot of information about the sites out in the public. The focus on functionality targeted at the users is, a lot of this, the aggregations, we didn't just build arbitrary aggregations. We went through their papers and looked at what statistics did they tend to report about sites. But we made the things that they most need to do, like communicate with the measurement sites, very easy within the system. The critical content, our biggest win was that we became the data download site. That meant that any synthesis team, any measurement PI who wanted that version of the data had to get a login on our site. That was huge. The ancillary data is also a huge thing. It's the only place they can get that ancillary data. I'm not even going to talk about the extraneous functionality because I could go on for days about the things we could have added that we would have loved but nobody else would have used. But really, listening to the users is the absolutely critical point, because there's so many of these pieces where you never would have thought of it from the computer science domain. Things like a water year. In the case of the Carbon-Flux, they want a MODIS week. What's a MODIS week? It's an 8-day week. Why is a MODIS week 8 days? Because the period in the MODIS satellite is 8 days. So if I want to compare to the satellite imagery, I need an 8-day week, right? There's a lot of things like that. But the really critical thing is you're not going to get anywhere with a collaboration site and providing these sort of services if you don't build a relationship of mutual trust. You got to think about that this is their science, this is their reputation, this is their career. And they're going to do a cardinal paper on a particular topic. It really matters for them that the data you're providing is accurate, well assessed, will always be there, will be versioned, will have all the properties that they need. And the other thing that really helps is have desperate users. And luckily we had that. When they looked at 960 site years, putting them all in Excel and doing formulas in Excel just really was not on the table anymore for them. Even a lot of the things they did in MATLAB were really not very good options anymore. So being able to have this sort of infrastructure was really a huge win. So just to give you the quick acknowledgements, it's actually been a lot of people involved in this. As I mentioned, a lot of folks at Microsoft, in particular Catherine Van Ingen, has been a huge help on this project. The Berkeley Water Center, our team is That's both scientists and the computer scientists in there, Marty Humphrey's team at UVA. And then all the scientists, these are just the key scientists in the collaborations, the Ameriflux and the FluxNet collaboration. As I mentioned, if you want to learn more about the site, www.fluxdata.org, you're also welcome to send to the support address if you have any questions about the site. That'll reach all of us. That's a little bit easier than giving you each of our individual emails. And there's some of the logos from the various sites that provided the measurement data. Those are the regional networks and some of the funding sources. That's it.
So we have a few time for questions, a few minutes for questions. Question in the back.
The first question about how big is the data set?
So the data is actually quite small. I mean, in the end, it ends up a couple of gig. So we're feeding it into. Oh wait, am I actually being accurate there? No, it's more than a couple gig. It's closer to like 50 gig. Because actually, we were trying to build a data cube on the raw half-hourly data, and it was way too big for it. But it's still sort of in the small size. In computing sciences, this is a joke in terms of size. But in the eco-sciences, this is huge amount of data. Did that answer your question, or did you have an...
I'm engaged with some people at the operation, also some people in China, when they're trying to cooperate on this flux data. The big issue is we're trying to, the thinking now is the data format and also how to share huge data. Because there was legacy data set, top managed, and also you're talking about this FluxNet equipment that basically producing huge data from the database.
Uh-huh.
How they can share this kind of things is pretty challenging for them. So they're looking for some less science things, not just also sharing the data, but also sharing the computational method. So they can download the computational method to the local data, use computation,
Okay, so one of the things we've tried to do as part of the Flux data site is actually provide support for the regional networks. So at the moment, that's primarily Ameriflux. But if you actually look on the pages, you'll find that there's a special page that's linked in that's got all Ameriflux specific data. We've also now been working with the Canadians to provide infrastructure for their biological and ancillary data to support the North American Carbon Program. We're very happy to work with groups to look at either providing some underlying infrastructure for a regional network, helping you to get your own infrastructure up, however you'd like to work. So I'd be happy to talk to you about that further. Any other questions? Yeah, Jeff.
There's one more.
NEON has come up with this idea of assigning a DOI to each of the data sets to get around this citation issue. So you can actually have a data set that people can get to that's completely recoverable and that can be cited.
Yes, that solves the synthesis team, that solves their issue. But the issue now is how does the guy that produced that data get enough credit? And in NEON, it's a little bit easier because they're already part of the underlying infrastructure. They've got their grant through NEON itself. So the fact that NEON can show that lots of synthesis activities use lots of their data, they already have a justification. In the case of Ameriflux and some of these predated infrastructures, they're individual PIs who are going out and getting funding themselves, or in small groups. And so providing the credit back to them is a little bit trickier. It's not that hard, but it's a little bit trickier, and so it requires doing a little bit more work to make sure that they are getting the credit.
Okay, thank you, Deb.
Thank you.
Any further questions we'll leave for the break?